You ever wonder how chemists know exactly how much stuff to mix together? It's not magic, I promise you. It's actually a lot like cooking if you're using a super precise recipe book. So today, let's crack open that book and uncover chemistry's secret recipe. Okay, quick pop quiz. 2 slices of bread for 1 sandwich. You've got 10 slices. How many sandwiches can you make? 5, right? You probably didn't even have to think about it. Well, believe it or not, you just did stoichiometry. Seriously. You used a ratio, 2 slices per sandwich, to figure out your final product. And that exact same logic is what powers modern chemistry. And you know what? This analogy is spot on. In the kitchen, you have your ingredients, you follow a recipe, and you get a finished dish. In the chemistry lab, we have reactants. We follow a balanced equation, and we get our products. That balanced equation, that is our recipe. So that leads us to the big, kind of scary word for all this, stoichiometry. I know, it sounds super complicated, but all it really means is the recipe book of chemistry. It's just the rule book that lets us figure out exactly how much product we can make from the ingredients we start with. That's it. Okay, so here's our first little challenge. With our sandwich, it's easy, right? We can just count the slices of bread. But in chemistry, our ingredients are atoms and molecules. They're so tiny, and there are so many of them, you can't just pick them up and count them one by one. So how on earth do chemists measure this stuff out? Well, they came up with this brilliant little trick. It's a special unit called the mole. All you have to think of it as a chemist's dozen. You know how a dozen is always 12? Well, a mole is always a specific and totally enormous number of particles. It's just a way for us to count things that are way too small to actually see. It's just like going to the store for eggs. You ask for a dozen, not for 12 individual eggs. Chemists do the same thing. They talk about and work with moles instead of trying to count trillions and trillions of single atoms. It's basically the standard measuring cup for the entire atomic world. So what is that magic number for a mole? It's this monster right here, 6.022 times 10 to the 23rd power. Yeah, that's a number called Avogadro's number, and it is just mind-bogglingly huge. But don't let it freak you out. At the end of the day, it's just a number. A very big one, sure, but it's just a number for counting, like how a dozen is 12. All right, so we've got our chemist's dozen, our mole, as a way to count our ingredients. Now we need the actual recipe that tells us how many of those dozens to use. And in chemistry, that recipe is the balanced chemical equation. This part is absolutely non-negotiable. It tells you the exact proportions you need. Without it, you're basically cooking blind. Let's look at a classic, making water. Our balanced equation tells us we need 2 molecules of hydrogen for every 1 molecule of oxygen to get 2 molecules of water. But since we can't count single molecules, we just scale it up using our new unit. So that means 2 times moles of hydrogen react with 1 times mole of oxygen to create 2 times moles of water. See that? That 2-to-1-to-2 relationship? That is the heart of our recipe. And that relationship, it has a special name, the mole ratio. It's the conversion factor that you pull straight out of the numbers in your balanced equation. For our water recipe, the mole ratio of hydrogen to oxygen is 2-to-1. And I'm telling you, this simple ratio is the secret key that unlocks everything in stoichiometry. Okay, listen up, because this is the single most important thing I'm going to say. The mole ratio is the bridge. It's what lets you go from a chemical you know about to a chemical you want to know about. It connects your ingredients to your final product. This is the one step so many people forget, but not you. From now on, you're going to see the mole ratio as your bridge. So, how do we actually use this bridge? It's a really simple 3-step journey. Step 1, you have to convert to moles. You'll usually start with an amount in grams that you can weigh on a scale. To get to moles, you just divide that mass by the substance's molar mass, which you can find right on the periodic table. Easy. Step 2, this is it. This is the big one. This is where we cross the bridge. You use that awesome mole ratio from your balanced equation to convert the moles of the stuff you have into the moles of the stuff you want. This is where you use that 2-to-1 ratio we talked about. This is the magic step. And finally, step 3. We just need to convert back to something we can actually measure in a lab. So you take the moles of your target substance, multiply by its molar mass, and bam, you get a practical amount in grams. That's the whole process. Grams to moles, cross the mole ratio bridge, and then moles back to grams. Okay, let's head back to our sandwich kitchen for a minute. Let's say we've got our 10 slices of bread, but we only have enough filling for 3 sandwiches. It doesn't matter that we have all that extra bread, right? We can only make 3 sandwiches before we run out of filling. Well, the exact same thing happens in chemical reactions. This is what we call the limiting reactant. It's the ingredient, the reactant, that you run out of first. And as soon as it's gone, the whole reaction just stops, dead in its tracks. It doesn't matter how much of the other stuff you have left over. It's the limiting reactant that decides the maximum amount of product you can possibly make. This quote just nails it, right? In the real world, whether you're making sandwiches or synthesizing a new medicine, you almost never have the perfect amounts of everything. Something is always going to run out first. And stoichiometry is the amazing tool that lets us predict what will run out and exactly how much we can make before it does. So let's wrap this all up. What are the big ideas? First, your balanced equation is your non-negotiable recipe. Second, the mole is your universal measuring cup. Third, and most importantly, the mole ratio is that critical bridge that connects everything. And finally, stoichiometry is the skill that puts it all together, letting you predict exactly what you're going to create. See? Not so scary after all. Stoichiometry isn't just a bunch of math problems. It's the fundamental logic behind creating literally everything, from a simple glass of water to the most complex, life-saving drugs. It is the language of chemical creation. So now that you have the recipe book, the only question left is, what are you going to create?